All right, 5.03, we're going to be continuing to construct recursive or explicit formulas for arithmetic and geometric sequences. Remember, we have a quiz tomorrow, so you want to be pushing yourself to really be working through each problem, deciding whether it's an arithmetic or geometric sequence, and then going back to your definition of each one to make sure that you're writing the recursive and explicit formulas correctly, and testing them out with the terms that you already have to make sure that your creation, your function, will work for future terms. The 4 problems that we worked on today, and what you want to do is you want to look back and you'll see where you ended up. If you finished all of them, that's great, then you can go ahead and move on. But if not, you want to pick up, either you want to redo the 2 that, maybe you did these 2 but you got this one wrong, so you want to go back and redo it, and then move through and complete each of them. And what I'll do is I'll talk briefly about the answers to each of these. Remember, you're assuming that the first term is when n is equal to 1. When n is equal to 1. So if you're creating a table, use that to help you out. And then we're going to move on. There's about 3 more questions, which I will give you an opportunity to try to prepare yourself for the quiz. So give this a try. I'll post the answers, and then you'll move on. All right, so here are the answers for the first 3. Pause the video and check those now. I want to talk about the 4th one briefly. So for the 4th one, here's what I'm trying to figure out. Is it an arithmetic sequence? In other words, can I be adding something at each step and get to 54 from 2? Or is it a geometric sequence? Can I multiply by a certain value, a common ratio each time and get to 54? Or could it be both? And what would be the explicit definition of each sequence? This is an advanced thought, but what we realize is that how many steps are we going to be taking to go from 2 to 54? Well, we're going to make 3 different steps, and at each time the pattern has to be the same. So let's just see what our geometric sequence would look like. Remember, we know that for a geometric, so we'll start with the geometric. We know that for a geometric sequence, a sub n is going to be the initial value, in this case 2, times the common ratio. We don't know that, right? This would be our r value. And in this case, it'd be raised to the n minus 1 power, right? Because for my first term, when n is 1, I want this to be 0, so this will be multiplying by 1. And we know the 4th term, right? We know that a sub 4 is 54, which has to be equal to 2 times r to the n. This is a sub 4, so it's 4 minus 1, or 3. So what we're looking for is what is the r value that will satisfy this equation. And you can actually solve this. So you can divide on both sides by 2. And you'll end up getting r cubed is equivalent to 27. And you know the value that when I cube it will be 27, right? R must equal 3. So this could be a geometric sequence with the r value being 3. And let's just think about what that would look like. I'll write this one in red. So 2 times 3 is 6. 6 times 3 is 18. And if you do 18 times 3, you're going to get 54. So this would be a geometric sequence with an r value of 3. And the explicit definition for this is going to be a sub n is equal to 2 times 3 to the n minus 1. All right, let's take a look at the arithmetic sequence. So we can follow the same idea, right? We're taking 3 steps. And we know they're all going to follow the same pattern. So what I know is that for an arithmetic sequence, the explicit formula is going to be the initial value, which in this case is 2. And then I'm going to be adding on to it the difference a certain number of times. So that's my difference d, and I'm going to be adding it on a certain number of times, or n minus 1 times. Right? So I'm not going to add it on for the first term, so there's going to be no difference added, 1 minus 1 for the first term. For the second term, I'm going to add on one difference, so that's going to be 2 minus 1, which is 1. And the second difference will be 2 differences and 3. So using this same idea here, I can use this fourth term, which is 54. So a sub 4 is going to be 54, and that's equal to 2 plus this difference here. And the n value is 4, so 4 minus 1 is 3. Right? Notice that for my arithmetic and geometric sequences, the only things I need to figure out are what is my pattern going to be. I know the initial value, I know this fourth term, I'm just looking for the difference or the common ratio. And so here I can solve for the difference. First I subtract by 2 on both sides, so I'm going to have 52 is equal to d times 3. And then I divide by 3 on both sides, and I'm going to find that the difference needs to be 52 divided by 3. Okay? So with a difference of 52/3, I can go from 2 all the way to 54 by the fourth step. I'll let you go ahead and figure this out. This is, if you want to make this into a mixed number, that might be helpful. So 52 divided by 3, you could make that into a mixed number. So 3 will go into, if you think about it, 3 goes into 30 10 times. And then 52 is 22 more than 30. And 3 goes into 21 7 times. So this will go in 17 1/3 times. So your difference is going to be 17 1/3. So if I were to create the explicit definition here, my d value is going to be 17 1/3. And so then I could use that to figure out what will my second term and my third term be, and you can check it will go all the way to 54. So that's an advanced idea, taking advantage of that we know what a geometric and arithmetic sequence look like. And if that was a little confusing, maybe re-watch it, retry it, and I'm going to give you another question like this. So go ahead, and once you are satisfied with all of those, I'm going to put up a few more questions for you to try to prepare you for the quiz. So stay tuned. Here we go. This is a pretty straightforward. Just make sure you are being precise and thinking about what term you're working with. I'll post the answer here in about 5 seconds. All right, so here is the recursive definition here, and then the explicit definition right there. Notice that we skip from term 1 to term 3, but the pattern remains the same. I'm subtracting 2 each time. And the big difference is the recursive definition requires that you know the term before, whereas the explicit definition only requires that you know the term number you're looking for. All right, here's a recursive definition. Write a closed form function, explicit definition, and use it to find the 150th term. All right, here it is. Notice that this is a geometric sequence. I'm multiplying by a half, that's the common ratio, and my initial value is 100. So my exponent will be n minus 1, because when n is 1, I don't want to multiply by 1/2, I want to multiply by 1. And so for 150, I get 100 over 2 to the 149th power. This is an incredibly small number because that is a huge denominator. All right, hope things are going well. We're moving on. So here, I have a sequence where there are some unknown values. So could the sequence be arithmetic? Could it be geometric? Could it be both? Explain and write out an explicit function for each. And then using the explicit function or functions that you found, try and find the 50th term. Okay, it's a little more challenging. Might want to go back and look at the one that was sort of similar to this. But good luck, and we'll talk about it in a second. So here, remember, if we're thinking about an arithmetic sequence, we're going to be adding the same value each time. So for my arithmetic sequence, my explicit function is going to be whatever the initial value is, so in this case 3, and then each time I'm going to be adding whatever the difference is a certain number of times. So in this case, I'm going to be adding the difference n minus 1 times depending on what term I'm on. Right? For the first term, I don't want to add any of the difference. It would be 1 minus 1. And so we can use this last term here to find the difference. And we can do the same for the geometric sequence. So great, so give that a try, and there's one more for us to take a look at. Here we go. So here I've graphed two sequences below, a red sequence and a green sequence. And I want you to determine whether each sequence is arithmetic or geometric, and then explain which will have a greater hundredth term. You don't need to find the explicit form yet. Just decide which one will have the greatest hundredth term. I want you to post in your comment along with your question whether you think the red function or the green function will have a greater 100th term. Then go ahead and check using the explicit form. So write the explicit form for each sequence and use it to check which will have the largest 20th term. So remember, in your comment, which one will have the largest 100th term, and red or green, along with your question. Hope this went well, and remember there's a quiz tomorrow, so make sure you have any questions, come by early and ask.